This video demonstrates the steps required to do the spectrophotometric analysis of the mass of acetylsalicylic acid in a commercial aspirin tablet. Our goal is to use this analysis to assess the accuracy of a reported value of acetylsalicylic acid in the tablet. This diagram provides an overview of the steps in this analysis. A single aspirin tablet is digested in 10 milliliters of 1 molar sodium hydroxide. This process converts the acetylsalicylic acid to the salicylate dianion in a 1:1 mole ratio. This solution is diluted to a final volume of 250 milliliters with deionized water. In a similar fashion, a known mass of salicylic acid is dissolved in 10 milliliters of 1 molar sodium hydroxide, which results in the salicylic acid also being converted to the salicylate dianion in a 1:1 mole ratio. This solution is also diluted to a final volume of 250 milliliters with deionized water. Because both acetylsalicylic acid and salicylic acid produce solutions of salicylate dianion in the same mole ratio, the salicylic acid can serve as a standard for the acetylsalicylic acid. Both of these solutions are further diluted with 0.02 molar iron 3 solution to produce the tetra-aqua salicylato iron 3 complex, which results in a purple color. The intensity of the color is proportional to the amount of the complex, and therefore to the amount of the salicylate dianion. It is also proportional, therefore, to the amount of salicylic acid in the standards and the amount of acetylsalicylic acid in the aspirin solution. Thus, the absorbance of the purple tetra-aqua salicylato iron 3 solution from the unknown aspirin solution can be used to convert to a concentration of acetylsalicylic acid in the aspirin solution, and in turn, ultimately to a mass of acetylsalicylic acid in the aspirin tablet. We are using PharmaSave brand of aspirin with a reported value of 325 milligrams of acetylsalicylic acid, or ASA, per tablet. The experiment begins with the digestion of one of these aspirin tablets in 10 milliliters of 1 molar sodium hydroxide. The solution is then diluted to 250 milliliters in a volumetric flask with deionized water, followed by a further 20-fold dilution in a 100 ml volumetric flask using the 0.020 molar iron 3 solution. The standard salicylic acid solution is prepared by precisely weighing about 0.11 grams of salicylic acid using the analytical balance. The solid powder is first dissolved in 1 molar sodium hydroxide so as to produce the salicylate dianion. The contents of the beaker are quantitatively transferred to a 250 ml volumetric flask. The salicylic acid standard solutions are prepared by pipetting the designated volumes into individual 25 ml volumetric flasks and then diluting with 0.020 molar iron 3 solution. Now that the aspirin solution and the salicylic acid solutions have been prepared, we are ready to measure the absorbance of each of the solutions using a spectrophotometer. In order to have the maximum change in absorbance with change in tetra-aqua salicylato iron 3 complex concentration, it is important to make the measurement at a visible wavelength where the complex absorbs as much light as possible. An absorbance versus wavelength plot for this complex has been generated previously and is shown here. Try to estimate the wavelength max by finding the wavelength on the x-axis that corresponds to the point of maximum absorbance, roughly in this region here. Hopefully this video has helped to clarify the steps involved in the spectrophotometric analysis of the mass of acetylsalicylic acid in a commercial aspirin tablet.